Welcome YouTube, this is Barrett from RProgrammingTutorials.com, and today we're going to be covering data frames. So what is a data frame? A data frame is basically a structure in R in which we store some data set. So we best understand this if we look at an example. Now in R there are a few built-in data sets that we can work with. So one of them is empty cars, and that's what we're going to be working with today. Now to look at empty cars, all we need to do is type in empty cars. We press enter, we scroll up, and this is the empty cars data set. Now what the empty cars data set represents is it represents a list of cars and measurements on those cars. So for instance, we have a Mazda RX-4, its miles per gallon is 21, has 6 cylinders, a displacement of 160, and 110 horsepower, and so on. And then we have a Mazda RX-4 WAG, it has 21 miles per gallon, 6 cylinders, and so on. So we have this list of cars, we have certain variables that we're measuring on this list of cars, and in fact we have a total of 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And in fact, in this data set, we have 32 cars. And we're going to figure out how to tell how many cars we have in the data set in a few minutes. But right now, let's look at a function called head. Now head, what it basically does is it prints out the data set, but it only prints out a small portion of it. And in fact, it prints out the first 6 entries in the data set. So we type in head of empty cars. We press enter, and we get the first 6 cars in the data set. We get 1, 2, 3, 4, 5, 6. Okay, and you'll notice it still has the 11 variables we're measuring on it. But this is useful. So say you had downloaded some data set from the internet and you imported it into R. That data set could have 400,000 entries in it, and printing it out would be impractical. And in fact, R would actually stop the printing out of the data set after a certain number of entries. And so you can't print out the whole thing anyways. So a lot of times, instead of printing out a ton of data points, I'll type in head and print out the first 6, because from there I can see the structure of the data set, I can see what variables are being measured on it, I can get kind of an idea of what types of variables they are. Most of these are in fact numeric data types, but we could have character data types, we could have what are called factors, which we'll cover later on. So I get a general idea of the data set by typing in head, and that's usually the first thing I do after I import the data, is I look at the head of the data. Now there's another function which kind of goes hand in hand with head. It's called the tail function. Tail of empty cars. This just prints out the last 6 entries in the data set. So I mostly use head. That's just what I naturally do by default. Tail will give you the same sort of information. It just gives you the last 6 entries in the data set. And so what I'm going to do right now is I'm going to define a variable called data, and I'm going to set it equal to empty cars. Okay, this isn't necessary, but I just wanted to create a variable in the global environment that represented our data set. So you don't have to do this, it's just for convenience. And one of the other reasons I did it is because when I was typing in empty cars earlier, RStudio kept auto-correcting to MMT cars, which was producing an error. And also, whenever I import a data set, you have to store it in some variable, and I usually call it data in uppercase letters. That's just something that I do because I always know, no matter what project I'm working on, that my main data frame is being stored in a variable called data in uppercase letters. It's just a preference. It makes working on multiple projects easier, and you may want to do the same thing. Maybe you'll do it all in lowercase, or you could call it something else. It's just whatever you do, you know, consistency actually helps out a lot. So now let's figure out, say we had this huge data set and we didn't know how many entries were in the data set. So for instance, we're working with a data set of cars. We want to know how many cars are in this data set. So we use a function called dim, which stands for dimension, and we put in the name of our data set, and we press enter. Now you'll note it spits out the values 32, 11. And the 32 represents the number of rows, or in our case, the number of cars in the data set. So we have 32 cars in our data set. The 11 represents the number of columns in our data set, which are the number of variables we're measuring on each car. So we're measuring 11, and you can confirm that by counting out across the top row the number of different variables we're measuring on each car. So we have 32 cars and we have 11 variables. Another thing we can look at is we can look at the column names. And we use the function call names, and we put in our data set data. And we get miles per gallon corresponding to the first column. We get cylinders corresponding to the second column. We get displacement corresponding to the third, and so on all the way up to carb corresponding to the last column. Now, the call names of data is just a vector. So we could look at call names of data, and then in square brackets, we want the first column. Whoops, didn't type in the L. Call names of data, first column. So we get miles per gallon, because miles per gallon is the first column. We could, just to remind you, I'm going to put in, list out the data here. First column is miles per gallon, as we got in this example. We could look at call names of data, column 3, and we get disp because it's the third column. So we could do that for any column all the way up to 11. Now, using this notation, we can rename a column. So say we didn't like MPG as the name of our first column. We wanted to use something more descriptive. And this actually comes in handy a lot. When I download some data set from some external source, a lot of times the names of the variables are kind of cryptic, or they're just not really named well. Or if you're working in industry and you're downloading from your database, a lot of times the names just aren't intuitive. And if you're working with the data, especially doing data analysis, you want something that is really intuitive, because you're trying to make these intuitive conclusions from the data. So you want something that you can work with. So if we wanted to rename the first column, we would do call names. Our data set is data. In brackets, we want 1 because we're renaming the first column. And we're going to set it equal to, in quotes, this is important because column names are character data types. We're going to call it miles underscore per underscore gallon. And we'll check that this is correct by doing column names of data. And we see that the first column name is miles per gallon. We can also verify this by looking at head of data. And we see that the first column is miles per gallon. So I'm going to change it back just to leave things the way that they originally were. So I'm going to say call names of data, column 1 is equal to, well, we'll use the arrow method, is equal to MPG, type in head of data, and we're back to MPG. So that's how you change a specific column name. Now suppose you had imported some data set into R and you wanted to change all the column names at once. You could do call names of data. Now remember, this represents the column or the vector of column names. So if you want to change the entire vector, you use a vector and you say, I want to name column 1, say call 1. Now you'd want to name it something descriptive, not column 1, but this is just as an example. You can name it column 2, and you go so on, but you need to have 11 different column names. And the column 1 is going to go into the first column, column 2 is going to go into the second, all the way up to column 11, which is going to go in the last column. So you need 11 columns. Now I'm not going to reassign the values because that would take some time, and I'm just going to leave them the way that they are. So I think I'm going to stop this tutorial here. We're going to have a part 2, and I'm going to show you how to grab specific elements out of the data set. Like, how do we grab this 21? Or how do we grab just this column so we can work with just the miles per gallon column, and maybe we could find the average miles per gallon for those 32 cars. Or, we could grab just this row and we can analyze, look at the data for just this car or just this row. Or we wanted to grab this whole chunk right here of these first 3 cars with these first 3 columns. We can do all this in R, and it's not actually that complicated. We're going to cover that in the next tutorial. So just to recap, what we covered today was we covered what a data frame is. We looked at the empty cars data frame. We looked at the head function to cover the first 6 elements within your data frame. We looked at the tail function to cover the last 6. We looked at the DIM dimension function, which allows us to see how many entries are in our data frame and how many columns we have or how many variables we have. And then we looked at the column names function, which I use a lot just to look at, what the column names are. You can also use it to reassign certain column names and redefine what they say, so to make them more intuitive. Or you can reassign all of the column names at once. And so that concludes this tutorial. We're going to work on extracting data in the next tutorial. And I hope you enjoyed this tutorial. Subscribe to the channel. Go to RProgrammingTutorials.com